Ever since it was realized that the stars are other suns, people have wondered whether any of them are accompanied by planets, or exoplanets as we now call them. Speculation along these lines were among the charges that led to Giordano Bruno being burned at the stake in the year 1600. It is only since the 1930s that astronomers seriously thought they had the observational tools to be able to find out. Exoplanets are almost impossible to see directly, because they are so close in the sky to a vastly brighter star, so the majority of the exoplanets that have now been catalogued are known only by indirect measurements. The Dutch-American astronomer Peter van der Kamp 19,011,995 thought he had found at least one exoplanet, orbiting Barnard's star just 5.9 light-years away, by measuring tiny changes in the star's position in the sky, a technique known as astrometry. He attributed these to the gravitational effect of the star's invisible planet, but other scientists were skeptical, and the star's apparent positional displacements were later shown to be artifacts caused by telescope modifications. A planet and a star orbit around their common center of mass. The star is much more massive than the planet, so its orbit greatly exaggerated here is only a tiny wobble. Image by David Rothery. It was not until 2010 that the first and so far, the only astrometric detection of an exoplanet was made, by which time other methods had become fruitful. Rather than measuring the star's precise position by looking for side-to-side displacement while the planet orbits, it has proved easier to measure the associated changes in the star's velocity as it is tugged towards and away from us. This is done by means of spectroscopy, using shifts in the star's spectral lines to track its changing velocity. This is the radial velocity method, and works only if we are seeing the orbit at least partly edge on. It can also tell you the planet's mass and its distance from its star. There are surely more exoplanets than stars in the galaxy. In October 1995, two Swiss astronomers at Geneva Observatory, Michel Mayor 1942 and Didier Queloz 1966, announced the first successful use of the radial velocity method to find a planet in orbit around a sun-like star called 51 Pegasi. An initial trickle of discoveries swelled to a torrent, and by the end of 2017 over 3,600 planets of other stars had been found, over 700 by the radial velocity method, and most of the rest by transit photometry, which detects the tiny dip in the star's brightness when one of its planets passes in front of it. This happens only if the orbital plane happens to be nearly edge-on to our line of sight, but ground-based and space-based telescopes are now automated to the extent that they can survey vast numbers of stars to detect and measure this phenomenon. There are about 20 billion sun-like stars in our galaxy, and although most are too distant for exoplanet detection, there are enough that are nearby which have now been surveyed for us to be certain that more than half of all stars must have planets. In a surprising twist, over the past 3 or 4 years we have discovered that among red dwarfs low-mass stars that are fainter than the Sun, and which outnumber Sun-like stars by a factor of about 10, around 90% have planets. Most of the first exoplanets to be discovered were giant, Jupiter-like planets. There was no surprise in this because large and massive planets are the easiest to detect. What was surprising was that many of these are very close to their stars. These hot Jupiters probably formed further out before migrating inwards. However, exoplanets of Earth size and indeed smaller are now beginning to be detected. There are several stars where as many as 7 exoplanets have been documented, and one, Kepler 90, where the tally was bumped up to 8, the same as in our own solar system by a discovery announced in December 2017. Thus there are surely more exoplanets than stars in the galaxy, and some of them probably between 1% and 10% will be at the right kind of distance from their star for the temperature to be suitable for at least simple life, such as microbes. This is an amazing prospect. For me, the biggest question left to answer is, given the right conditions, how often does life actually get started on other planets? Unless life is an incredibly rare fluke, there ought to be life of some kind all over the galaxy. We haven't found signs of it yet, but are on the verge of being able to detect the effects of life on the atmosphere of an Earth-like exoplanet as it passes in front of its star. An exciting, though possibly tantalizing, decade lies ahead, as we are still a long way from being able to go and take a closer look. Featured image credits Sunrise Space Outer Globe World by Quimono. Public domain via Pixabay.